this is course for Open RAN interoperability. We have interoperability in implementing Open RAN. Basically, we want to make, of course, various components of this new framework to be working as intended. And since the main concept is to break down this monolithic radio access network that we had for quite some time, since until 4G and until 5G now actually. Or the vendors or the telcos wanted something more bite-sized, where they could have best of both worlds, and if they need to upgrade certain components, they don't have to buy the whole ecosystem. They could upgrade specific components for their benefits. So for our topics, we'll have key principles for interoperability, some discussions on open RAN standards, just a recap, and then RAN, including RAN intelligent controller. Then we have yung standards for interfaces and a sample of end-to-end testing and equipment and platform that we could use for that. So for key principles of interoperability, we have, of course, why we needed interoperability in the radio access network. Since yung mga monolithic deployment before was proprietary, yung mga protocols to specific vendor, if a feature from another vendor is required for the deployment, for the most part, you cannot really do it, and it's going to be too expensive. So they felt that out because they cannot afford to redo the entire radio access network just to have that specific feature if they are tied up to a certain vendor. Hence, Open RAN was created to modularize what we can, like radios, hardware, and software in a RAN. So another feature, of course, of Open RAN is the RAN intelligent controller, which you could add programmability to the RAN. And the problem with monolithic deployments before is you technically do not own the equipment. May ganun, parang you bought it, you deployed it, but for what it's worth, you are just licensing yung equipment. Kasi if you need some modifications on it, chances are you don't have the capability to do it. You would contract yung vendor na kung sino man yung nakuha niya sa RAN nyo. They would do it for a fee. They would deploy it and test it, and for the most part, it's black box even to our largest telcos here, in the Philippines. So the interoperability part somehow breaks that that monolithic deployment, where you could again purchase specific vendor that yung features niya yung need mo, and this would also allow you to yung mga interfaces niya allow you to be able to program or mix and match various vendors for your specific feature requirement. So again, one of a few of the features that interoperability is attempting to solve is we wanted to eliminate proprietary hardware and closed systems, which has been the standard for the past few decades. Where if you need to buy or deploy a telco, typically go before with Nokia and Ericsson. At least that's the two main vendors here before, and some others. Then recently we got Huawei competing on that field, but it's all their deployment before Open RAN would be one system, and it's end to end. They would own it. There are various things that you could carve a bit, but still you are vendor locked in for that specific big chunk of your infrastructure. Okay, and Open RAN interoperability basically breaks that apart. And with those components na is modular and you are now not tied up to a specific vendor, no? There are a lot of innovations in AI, machine learning, continuous integration, continuous deployment, software-defined networks, network function, and supply chain diversity. No? So in case something went wrong with a specific vendor, no, you are not tied up. Uh, you will not lose your service. No, you could get another vendor to supply that component for you. No? So this also makes it yung innovation, no, at every component of the network stack possible, and you could get the best of both worlds, no? Best of all worlds on what ever a vendor is releasing in the market. No, you don't have to replace your entire stack. You could just maybe analyze it, and maybe if it's not proprietary and not patented, no, you might be able to implement it on your own. No? If may mga research that is publicly available, no? You could implement it on your own. Or maybe a third party, no? Not necessarily yung vendor that you bought your equipment. So sample nito would be healthcare interoperability. So this uh, is a story of how healthcare basically for the past 40 years of evolution nila, no? How they adopted, no, to technology and interoperability. So in the early years, no, they had fax, phone, or mail, no, to share patient record, and mail na, it's not email, no. Wala pang email at that time. Well, technically meron no 70s, no, but of course it was too expensive and not everyone's connected. So this is physical mail that they use, not the doctors use to share patient information. So it's very clunky, very slow to our standard, and confidentiality of patient record is not there. So it has to be readable if you have to fax it or send by phone. No, it's not encrypted. But it is somehow an interoperability kasi if you have a fax machine or a phone call back then, no, or even mail, no, as an address, um, it is a sort of communication, and if you know the format, no, on how to write a mail, nasaan yung source, address, nasa yung destination address, so typically like a protocol, you would be able to send and receive mails. Same with phone and fax. No? If you know the number and you have the equipment, you would be able to send and receive message. No? But that's about it. It's more of message transmission. Then health data, basically when computers and connectivity, no, was booming during 1980s and 2000s. Electronic health records, no, brought this digital interoperability where health data exchange becomes a priority. So we got health records now with formatted using XML and acceptable, no, fields. We also have encryption at that time. Well, not too much, no. Wala pa masyadong concept of data privacy during that time. But I mean there is, no, but hindi siya as pronounced as today, you know. And then 2010 to until now, no. So it's been for the past maybe 15 years. Most healthcares would now need, no, computerized system connected to a central location, no, to gather patient records, insurance, and you're seeing this, no, in a hospital environment, even multiple departments, no, within a hospital, and they would have different branches too. They would be able to communicate and have your data, no, online, even on their systems. And we got some of these benefits, no, like if you do some tests, you would be able to receive it via email. I mean, of course, it's not technically interoperability, but it's a mode of delivering results, no. Unlike before, if you've been to a hospital maybe 15, 20 years in the past, no, so you're gonna have some tests. Either you wait 4 to 8 hours on-prem, which also increases your chance of getting infected with other hospital-borne diseases, no, or now just extract yung blood or kung ano man yung needs testing, and then you just wait at home, no, for the email to notify you that yeah the result is out, no? And then you could go to the site, no, to download and have another doctor read your results. And even you could even bypass all that, no? Pwedeng diretso sa doctor yung results and yung diagnosis na kagad yung i-message sa'yo without you being needing to be physically present to wait for the results or coming back, no, which takes up more time. Nami-miss ka na nga, pabalik-balik ka pa sa ospital. So that's sort of benefit that we had, no, when uh, checking out how does interoperability actually benefit, no, certain you call this I lost for words, a certain vertical, no. So yeah, just an example, no. So for open and interoperability, no, even until 4G, no, and some 5G deployments, again, these are um locked in the vendor until Open Run attempted, no, to break this in 2019. No? So it was Open Run started 2019. It has backings of a lot of big industry players. No? And they want initially is, well, if we could break down OCU, ODU, and ORU, no, and have this proprietary interfaces not be present, and it's gonna be standardized, and anyone could create their own hardware and software and integrate with OpenRAN. Then that's what we intended. That's what OpenRAN intends to be able to come up with. So with multiple vendors, no, and systems at play, we needed a way to have testing, no? So you cannot test, of course, on production. Well, as they say, no, everyone has a testing environment. Others are just lucky that they have uh, a staging environment. And others are not lucky; they test it properly. But of course, on a critical infrastructure that has needs to have minimal downtime, you can't do that. But of course, there's a cost for staging environment, no? And there are systems, no, that you could purchase or set up, no, or you could even have a parallel small scale version of your environment where you have emulators and then or various components, no, and then you could fit in, no, yung specific product that you want to test, no, if it integrates well to your environment. And of course it's standard, no, but some of these products would still have features that they supposedly claim na sila lang meron, okay, and you want, diba, how does it perform on a load, no, or with on a load like our environment, and then with our components, no? So of course if you break down this pieces, no, in Open Run, you'll probably have a mix of vendors na ikaw lang yung meron. And of course, better to have a setup of a test environment with same specs, same hardware, same vendor, no, and integrate on the testing yung product na gusto mong implement in your run. And yan, part of our requirement would be readings, no? So we would be dumping various reading materials. I think for this one we have 3. No? And some short ano lang summary, no, yung required for the students to come up with that documentation. And it's gonna be part of course yung course requirement. So aside from reading, we have just a very short final exam. Kasi again, this is text heavy, not too technical, more of descriptive siya. So we have, I think, 15-20 item na questions for the finals. But the rest would be just readings and assessments. Okay. So I'll skip the OU, yung recap kasi diniscuss naman ni Ma'am Joseph ito kanina din. It's just to refresh, no, kasi if you're taking this course na hiwa-hiwalay. Okay. And sorry, if you have any questions, please feel free to chat. I'm monitoring the chat box. If you need some more explanation or baka may tanong kayo about that specific slide. Okay. Next we'll be discussing yung Open Run standards, no? And Open Run, basically, again, you allow any organization to create run products, and they don't have to do end-to-end at this point. No? They could just find what they're good at or what they want to dominate, no? And concentrate on that spec or module in Open Run. No? Means if you are good in software development, then you don't have to concern yourself with developing radio components or the cloud components. So you just concentrate on the software. If you're good in cloud, maybe setting up, no, not really a cloud provider, say that has been dominated na by major players like Azure, Cloud, Google, and AWS. Well, we have some small players like Linode, DigitalOcean, no? But for critical infrastructure like telco, you would usually go with the three, no? Dominant cloud providers. No? You don't have to recreate the cloud, no? But if you know how to use their services efficiently, if you're a cloud engineer, or cloud architect, no, you could leverage your knowledge there in Open Run, and be or even develop future standards, no, on how to deploy this. Okay. For Open Run standards, no, there are two dominant standardization bodies. No? So it's ORAN Alliance and the Telecom Infra Project, or TIP. So both of these organizations, no, they lead the alignment and development of interoperable Open RAN technology, including, of course, sharing of information, diba, referencing specification. Mainly, a lot is still points to 3GPP standard. No? And then, of course, conducting joint testing, no, and integration efforts. So if a vendor comes up with a product na, oh, this is going to be a component of Open RAN, you need to test all the interfaces, all the API calls, all the specs. No? First is paper check if is it conformant to our standard, no, ORAN or TIP, or maybe combination of both. No? And then once they said yes, and the papers checks out, no, you could now put it into a test environment, and then that has all the components, no, except for that new equipment. No, even emulated test environment should be all good, and then run through the product, no, and see if it behaves as intended on the spec sheet. We all know naman that especially in computer um, spec sheets, no, vendors would sometimes claims na ito yung let's say ito yung kaya nilang throughput, ito yung fault tolerance nila, no. Well, for the most part it works, no. But sometimes yung mga fine print, no, na parang ganito yung specs if ganito yung setting, no. And we might miss that, no? And we want, of course, test those end-to-end sa isang Open RAN network with that component at play. And yeah, as mentioned, you cannot do that on a production environment, ideally. So the Oran Alliance, no, has actually already created, no, more than 30 specs, no, and many of them defining interfaces in Open RAN, and that's where a lot of this how do you call this course, no, delves into define it, no, not really to how do you call this how to interface with it, but again, this is an intro course for interoperability, so we will be describing those on the next section, yung Open RAN standards for interfaces. So you've seen this Ma'am Josel din, no, na slides. So this is the ORAN architecture, and you have various interfaces for this. So we have sort of important interface. I mean, everything's important, of course, to work, no, but for our discussions on these courses, we'll be defining this various interfaces listed here. And again, some or most of these are actually from from 3GPP. So we start off with the open fronthaul interface. This connects the ODU and the ORU, no, and breaks down basically to management plane and uh, and the control user synchronization plane. No? And you can see it here dito sa interface, no, where yung open frontal interface would be here. I'm not sure if nakikita niyo yung mouse. No? It's on medyo lower left, a bit middle left actually. Open frontal yung M plane, that's the main one. And then yung connection ng ODU tsaka ORU, no, that's in between those two red below. Nandun yung open frontal CS plane and then open frontal M plane to connect these two components of OpenRAN. Next, we have the A1. No? This one enables comms between two RICs and supports, of course, yung policy management, data transfer, and machine learning management. No? This is how they would support each other, no, and pass various information. No? And actually, this data na tinatransmit dito sometimes called enrichment information and assist for model training, no, for the AI. And machine learning in the near real-time rigs. And you could see it here sa architecture again. No? That's the green interfaces that connects non-real-time rig and yung near real-time rig. If may information yung isang component pa na kailangan ng isa to be more efficient, no? They would be passing that information or telemetry, no, between the A1 interfaces for these two components to talk to each other. Now, next would be O1 and O2 interface. This connects the server's management orchestration component to run managed elements. And it actually connects a lot. Includes yung near real-time rig, OCU, ODU, ORU, and the open evolved mga nodes connectivity. No? And if you want to see yung placement niya, no, sa architecture, O1 and O2 is on the left side. Okay? O2 connects basically the O cloud and ORU. Si O1 connects dun sa nodes. And then another O1, no, dun sa rightmost, no, connects again various components, no. Meron siya papuntang real-time rig, meron siya sa OCU, meron siya sa ODU and ORU. So that's how they would do it. So O1 connects to everything, O2 connects to O cloud. That's yung placements niya. And then we have an interface, no, originally designed by 3GPP, mga XT no, and X2C and X2U interfaces, where the former is the control plane and the latter is for the user plane. And may mga ano rin, interfaces, no, na may for subtypes, no. If you have more, basically needing to interact various components. And if you could see dun sa architecture, it's on the left part, no, nung architecture. Nandun yung mga X interfaces. No? So X2 and then XN. No? It's on the rightmost. Okay. Then we have NG interfaces. This NG interfaces basically connects an OCU control plane and OCU user plane to the 5G core. And then of course this has something to do with yung mga 5G access and mobility functions and nagre-receive ng mga session information ng mga user equipment, so like mobile phones. User plane information goes to 5G user plane function, which handles many aspects, no, nung iraroute ba natin to, forward natin to another component, or is it tunneled, no, baka roaming pala, no? So we need to tunnel it to the real home network ng user. Okay? So that's where the NG interfaces place, no? And yung placement niya sa architecture nandun sa rightmost, no, kasama ng mga X interfaces. Nandun yung mga NG user at NG control. Okay. So, medyo patapos na yung interfaces. We have F1 interfaces. This one Again, broken into control and user plane subtypes, no? We connects the OCU CP and then OCU UP, no, to the ODU. And this exchange data, yung mga frequency, resource sharing, and other network statuses, no? Like if you are maybe running a shared network, no, or shared antenna, pwede mo sigurong i-distribute data na, okay, ito yung frequency ni Telco A, ito yung frequency ni Telco B, and they are basically leasing, no, yung equipment sa'yo. Maybe you could split that, no, and then feed it to various networks, no, as kung kanino mang frequency yung allocated for that. But yeah, one OCU can communicate with multiple ODU, no, via these F1 interfaces. So you could reallocate that as intended. And yung F1 interface, if you could see, no, that's black one, no, pero itong OCU-CP papunta sa ODU sa gitna. And then medyo on right, no, that yellow part na OCU-UP papunta rin dun sa ODU pababa sa red na module. And last, for our definition of interfaces, no, we have E1 and E2 interfaces. This connects to disaggregated OCU, user and control plane. No? So if you have multiple OCUs, no, you could transfer configuration data and capacity information between two OCU, where maybe one is loaded, no, since I'm not sure why, pero sa kanya napunta yung mga requests and sessions and needs computation. No? So more than yung nasa isang interface, no, or maybe sharing lang sila, no, equally load balance across multiple of these, but one component needs to be serviced, no, so and it needs to pass yung sessions, no, to another OCU or distribute it across multiple OCU kasi may maintenance na gagawin, it's gonna be shut down, and we don't want customer interruptions, no, so they might you might want to redistribute that information, and of course you will be doing it automatically. Let's say you command one OCU to shut down, no, it could start propagating yung mga current sessions niya across multiple other OCUs na alive pa. Okay? Para once na zero na yung sessions niya, they could start shutting down and maybe do some maintenance. So for the E1 and E2 interfaces, you could see them dun sa may near real-time controller, no? That's the E2 yung green, no? Papunta to various components. But mainly E2 and E1, that's yan. If you could see OCU CP, tsaka OCU UP, no? It connects, it's connected with each other via the E1 interface. But these two components, no, are also connected via the near real-time link, no? Again, if they need to offload or get some other telemetry or session data from others OCU, they would be able to do it using this interface. Okay. So next is we have ORAN, end-to-end testing. We have the current documentation that was released last year. No, it's last I checked, this is still the latest, current version 4. This describes, no, integration focus groups, test and integration focus groups, end-to-end test specifications. This is a bit of a lengthy document, but summary is, if you have a component, no, or a system under test, saan siya ilalagay in this end-to-end testings, no? Typically for Open Run, it's just gonna be this component dito sa yung second module, no? And you have, of course, yung user equipment passing through the Open Run, and then you're gonna, of course, once you process it, no, send it out to the 3GPP core, no, and touch on other 3GPP services. No? Oops. And if aside from system, no, and interoperability testing, security testing is also going to be part of yung test and integration focus group. So sample here would be a description on that document on how and why, no, do we need to test exploitation of well-known vulnerabilities doon sa A1 interface, no, or by the network layer. So again, since these are API calls, no, is the SMO's IP address accessible or routable within a certain infrastructure, no? Let's say nasa user equipment ka, no, and then could you actually see the A1 interface of the SMO or the near real-time brick, no? And ideally hindi dapat, no, but that's baka may missing dun sa mga firewall configuration and routing information natin, no? Or hindi missing at dagdag. And if that's the case, no, or maybe that's not the case, it's um, secure enough, no, but for some reason, if a threat actor is able to gain access to the environment and could see the A1 interface and host, no, could they actually do something, no, on it and compromise that box? So kaya blind exploitation na to, parang since a lot of this would be running core operating systems then, no, like Linux, likely not Windows, no, but hindi ba properly set up yung Linux wherein someone could exploit a specific well-known vulnerability. So again, these are not 0 days. These are maybe Linux or application vulnerability that has been known but hindi na patch ng operator, no? Or ng vendor na when they deploy this system. So it's describing that, yeah, if someone had access to the A1 interface, could they actually do some damage? Maybe not full code execution, no? For this, no, but maybe even a denial of service, no, if they could flag that interface and do various requests, even trash requests, no, just to exhaust yung resource, no, nung gumagamit ng A1 interface, then you might cause an outage kasi that would basically disconnect, no, the A1 interface from ORAN, and you won't be able to perform, no, as intended. So here's some test procedures, no, on the exploitation of A1 interface over near real-time brick, no, by the network layers. So sample here is if you could see it, no, or maybe you would intentionally, no, put your test vulnerability scanners within the subnet, no, of the A1 interface, and you have a list of well-known vulnerabilities, yung mga signatures and plugins nila, and then you have your common vulnerabilities na exposure list, no, CVEs, and document, no, yung actual version ng vulnerability database sa signature natin for reference. Kasi when doing vulnerability scanning, you need to note what database version you are using, kasi this specific database version might not or will not detect some vulnerabilities that would be released on, let's say, vulnerability database next month, no? So if sometime something happens, no, and you said na hindi, nag-test na kami ng security sa A1 interface, no, using a vulnerability scanner, but when you saw the report, no, the system was breached and the vulnerability wasn't listed dun sa test mo, you could go back dun sa time of test and then yung vulnerability database na ginamit. And you could also see, no, here, if you conducted the vulnerability scanning and you did not update the database kung ano man yung latest at that point, no, then that might not be the best approach kasi you are not detecting other vulnerabilities that was recently discovered. So like antivirus, even the vulnerability database needs updates, no? And for testing, no, you need to note that so that in case magkaroon ng deconflicting, no, in case something happens in the future, you are covered na. Yeah, I tested November 11, sabi ng vulnerability scanner database, this was the latest version nila at that time, then that would be easily traceable. Hindi tayo naging negligent on testing, no? But again, this is security testing, no? Not really yung mga load or interoperability testing, no? But it's part of the document specs, no, netong ORAN na test and integration focus group na end-to-end test specification. So to sample vulnerability scan, no, would be if you have the IP address of the A1 interface, no, scan with port scan initially, no, TCP ports, all ports, 0 to 65,535, and then UDP top 1,000 lang kasi this tends to be slow. You need to also, if the 1 minute scanner enables or has this feature, no, yung save checks, disable it. Kasi test environment naman, so in case the A1 interface crashes, no, it should be okay, but at least you know that you could crash it, no, with some basic vulnerability scan. And then while you're doing the scanning, no, you have some telemetry data or even load testing na kasabay. Could the scanning actually degrade, no, yung performance nung system? Ideally, hindi. No? The system should be able to defend itself. And most of these scans should be dropped anyway. No? So, wala dapat affect dun sa environment. And then, yung results, no, expected at least. Na once you have conducted that, yung telemetry mo is okay. I didn't have any performance degradation. And then, you need to measure, of course, yung throughput, no? As benchmark, no? And then in case may how do you call this? In case may degradation, you should be able to find out, diba? Kaya ba i-resolve to, or should we just note it's an exception? Ito yung ano, medyo parang weird, no? Parang if you do that, no, you are not actually wanting to identify, no, well-known vulnerabilities, no? Out of scope siya for this test. It's, well, technically blind naman siya, no? So it's just someone, a threat actor, not really realizing kung ano yung ina-attack niya and then attacking it. That A1 interface anyway is not gonna be exposed to the internet or to a public network. So this is a threat actor na meron ng access, some sort of access within the environment. But he just doesn't know kung ano yung IP na yon na A1 interface pala yun. So blindly niya tinatry i-attack. And the metrics that they are after here is, okay, if an unknown threat actor with some access to the system and did vulnerability scanning, it should not cause meaningful degradation of service, no, and availability. Okay. So at least that's just one, no, and that's a lot. There's a lot of tests across networks and interfaces, which makes it basically a required reading for this course, and medyo mahaba siya. But interesting, no, on ano yung views nila and how to perform that test and unexpected results. So that basically is the meat of yung Open RAN Interoperability course. Now we have sample testing platforms just to pick your mind, no? Paano ko ba gagawin ito if I wanted to do it. So this one is from VIB Solution, no? But it tends to be expensive. We're trying to build an Open RAN lab. Hopefully, if we could get funding, no, maganda tong VIB, no? But again, medyo malaking budget yung kailangan to solve this. But malaking budget because complete naman talaga yung environment nila, na marami silang pwedeng i-emulate, and then you could have yung component na you want to test, no, to replace that emulated part, and then plug in your component, and then get the telemetry out of it, no? It is good, no? Expensive but good. If we want, but I think mukhang ito yung next, no, best natin. Firecell, no, meron silang lab kit ng 4G and 5G hosted on one machine with a software-defined radio na may mga SIM cards din, no, na you could really interact with it as telco, mini telco, no? But the cost, of course, still expensive, no? 11,900 euros. I don't know the exchange rate, but I'm predicting this is around 650 or 700,000 pesos, excluding tax and shipping, if we need to purchase this. And of course, plus support, no, if needed. And most likely we'll need support, which is gonna be, lalo na pag platinum, no, multiplying yung ano. Yes, kasi baka meron tayong specific feature or telemetry that they haven't implemented yet, no? If you have the platinum support, then you could ask them, no, to create this and get you a new software for your testing needs. So interesting yung features niya, no, for even for that price, no, na with support maybe a few million, hindi mga few million. a million plus the pesos, no? So yeah, you could have 16 4G devices, 10 5G devices, and good throughput, no? 70 Mbps for download and 7 Mbps for upload for 4G. Then for 5G, you have 100 megabits per second for download, and then 20 megabits per second for upload. So good enough for testing to, but not system load testing. I would say, no, you would need VIB solutions for that, no. But for maybe some component, no, if it works, no, you want to test it, then yeah, this might do, or lab setup, no, for schools. I think this is a good starting point, no, for the testing platform.